Okay. I'm back here. This is basically the video is on Muko OS, M for Mike, M for Mike, U from Bala, K for Kilo, O for M for Mike, M for Mike, U from Bala, O for Oscar, K for Kilo. M for sorry. Today's date is the 6th of the March 2026. Time now is 3:45 p.m. This is on Muko OS, M for Mike, U from Bala, C for Charlie, O for Oscar. The Ohio division of Muko OS. So I'm gonna draw something here. Basically, we're gonna have two type of models here. This one is very important to understand, Namdi. It's for you. So we're gonna have the HTML5 canvas doing it. We're gonna try to draw a lattice. Use the lattice to draw some things. So the goal to have these lattice properties will be computed as SVG equivalent of a lattice. So you have a raster model and rather one of the tables which I'm drawing and an HVG being computed ahead of time on the fly execution for the lattice model. So let's go to geeks for geeks here. So mathematically, this is an object, so this is basically lattice. Lattice. So given a circumference circle of radius 2D, origin 0, lattice find the two lattice points on the circumference. Lattice points are the coordinates as integers on 2D space. So you're gonna have a system of lattice. For example, to find lattice point, we basically we need to define find the first x y values, which are equal to s squared plus y squared equals r squared. For any value s squared plus r squared, we can satisfy the equation. We need to have a total different combination for which satisfies the equation. For example, if r equals 5 and r 5 and 3 4 is a pair, because which equation we do is an actual combination 3 4 minus 3 4 minus 3 4 minus 3 4 3 4 3 minus 3 4 negative 3 negative 4 3 negative 4. Take exception. There's no exception though in case of 0 r and r 0, which are the 2 points with no negatives. So let me go to this is basically gift for gifts lattices, but I'm trying to use a circle lattice point. So let me continue. So we're going to have the formula s squared plus as you heard s squared plus y squared equals r squared, where the 4 points on the lattice lie for the 4 points lie in the lattice such that they do not they have 4 origin points that can be scaled. So these points have rotation, reflective symmetry, and so because to have this transform via the inverse color, so go to have the 4 points as a vector point mapped to a vector brush. Now, the vector brush is a vector canvas that allows you to draw and animate on the screen in the HTML5 canvas and export it as raster graphic or export it as vector graphic. You need to have an exportable vector animation while you're via the principal animation. So the problem is one problem you can use to utilize this for. Now, lattice is let's go to Geeko here. So let's read this. So let's read it here. Okay, below is an impression on ideas. So let's try Java, Python. Okay, Python. Let's just use Python. Let's go reader mode and look at Python. So Python code is here. So import math. So let's just run this code here. So import math. Define count lattice in Pascal mode. R. If R equals 0, less than equal to 0, return 0. Return result equals 4. So the result is 4. Use away from 0. It could be 1. It could be 1. for x reaches 1 to r, y squared must was was the square root. Basically, it's source equality formula. Yeah. So basically, print count lattices 12. So the 12 lattices lie in these 2 points. Because the root is 5. So this is basically a system of lattice multiplication. So this is going to give for articles. So give for articles. So let me try to do so. So, for example, if you have the radius of 9, 3, y equals radius equals radius equals you have input radius equals 7. You have the output is 12 because before that is single point, below is that is so you're gonna have the radius and the origin of 0, 0. So you're gonna have to solve a quadratic formula using these inputs. So you can model this as a symmetric equation. So you're gonna have a bipolar equation. So you're gonna have x squared plus y squared plus I squared. You're gonna have so you're gonna have the other equations. You're gonna have the points, and the points are so below are the points and circles equals. This is example r equals 5 and origin is 0, 0. And if the origin is somewhere else, that is lattice. That is the frame of the 0, 0. So the lattice frame of reference is 0, 0. That's the origin. But that's 0, 5 minus 0, 5, 5, 0, and 0, 5 minus 5 is 0. And the lattice points are 3, 4 minus 3, 4 minus 3, 4. So the 12 lattice points you can have the conjugate model flip. You can flip. So the goes to have the lattice gives you the point of the system, but they are for the SVG. Basically for the SVG, you have from the origin, you have basically for the continuous system, you have the sequence of 3, 4, but it's 3, 4, minus 3, 4. In 2D, it's a pen you can draw in 3D too. So it's a 3D pen basically. Sorry, it's a 3D paintbrush. So, I'm going to try to formalize it properly on my paper here. So, you're going to have circle lattice points. So, R is the radius of the system, R is the radius of the circle. So, you're going to try to do an example. So, R equals 7. And you start with the points 5. If R is 5, 4, and okay, and a point point 3. So, I'm going to do a pair of pointers. And it's a pair, that's an equation. So the pair will be actually the pair there's a point in 3D and point in 3D in R3 which is which side is the equation which where P is P is a natural number. A natural number between is a natural number between is given a natural number between 10 and 30. 10 and 30. So basically, I picked a random point 0, basically 10 and 30. So the point will be let's pick 2 random points for. So we're gonna put the point A equals 11, 13, and 16, and point B will be 16, 17, 18, and 11. 17, 18, and 7, basically. So you're going to have 2 points here. So the first permutation of the points will be, there'll be how many permutations will be? There'll be a point A, point A will have the resultant of 11, 13, and minus 11, minus 11, 13, and 16. Minus 11, 11, 13, and 16 as a pair. Gonna have 11. Gonna have minus 11, minus 13, and minus 16 and 16. Gonna have 11, 13, and 16. Gonna have the conjugate of that. Conjugate will be okay. Let's use 2 points. So the goal is to have this permutation over the system of R space. So R space will be the points that are there, but these are non-negative. So so you're gonna have some for counter. So the catalyst system. So if R equals to 0, the R is reduced of minus R. You're gonna have R equals 4. But for range of 1 to R, there's this Y equals square root of to a computer here. So there are how many lattices are there? So there's a 4 letter. So 2 cubed. So 2 cubed is 9. So basically, there are 9 lattices for the 3D space. 3 to the power of 2 is 9. Because you have 3 points and you square them. You cube them. So, the goal to have lattice. So, basically, my point is to demonstrate that, I'm trying to demonstrate that, you can use the lattice to draw something. And not just a just structure, you can use it to draw something. So, you use it to draw a smooth curve, via by taking a measurement of, vector measurement, a local vector measurement. So, local vector measurement. So, now let's go there. So, give for geeks, lattice DTSA. It's called a distribution algorithm. So, lattice. So this is the lattice. So this is Academy. Oh, I love this Academy. Which is a lot of ads here. There's a lot of ads. I'm going to play the ads, but the ads are going far too long. So basically, the goals have defined a lattice of space. You can map this system. So the solution space lies in the lattice point. But the lattice point, the local lattice point can converge. Basically, this is taking too long. So let me just play the video here. So analysis of fundamental in order 3. So the order of the equation matters because there's analysis. So the analysis is a particular kind of order set, a post set. That has different properties. In analysis, every pair of the element has unique less of the join and a greater mean. So the join is before to get the join and the mean. So the join. So example A disjoint B equals join join the smallest element between and the meat. greatest lower bound. So 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 get A identity law. So join a mutual gives the element's name. So this joint an M for itself gives an element name. Join an M for gives an element name. Um, there's joint an M from B commutes laws. Because it was operation orders or operation does not matter. So B join M. Associative laws grouping of operation does not matter. So you can identify group observation. Observation of along the journey is a pattern. So the table has that is a basic boundary. This is a boundary system A, B, C, D. Every finite lattice will be bounded. So let me do this again. Have so how would you use this in practice? So basically, you have a canvas. The canvas has if you have a stone center, I have a lattice. So let's call a modular if you certify what is an L for all L. So A is joined B given an A, given B and C, 0 destroying B and C, where B is alpha. So the alphabet is defined as 0, so 0, B, and 1. So 0 is alphabet addition from B. Now B is another alphabet, and 1 is equals 0, B, 1 equals B. So it's a coding system modeling. So you're gonna try to do this now. So basically, I'm trying to find out why. How we can go right, but let me try to have a string. So we're gonna have a string. So you're gonna have so you're gonna let me just give this one point. So you have some. So you have a lattice, a disjoint lattice, so a distributed lattice. And why am I using a distributed mod lattice? Um, meet join meet equals condition. So for example, identify meet and join in a given set L. Let L equals 1, 2, 8, 4, and 8 be partially ordered by the variable A less than equal to B if A divides B. Find 1, 2 disjoin 4, 2 join 4. Join least common multiplier. 2 disjoin 4 is 4. So join is for meet, which GCD 2 join 4 is 2. Given lattice derivative, consider that given lattice given this derivative, consider L theta. Oh, so that's language for A. A is a set subset B and C in order of set inclusion. Is L the yeah, L is a meet equals set union, join equals set union for two checks. So X union Y union Z equals X union Y union X union Z times X union Y union Z equals X union Y union X union Z. No. Example, take X equals A, Y equals B, and Z equals AB. LHS, so least common multiple and Greek common divider. Look what it. Yeah, this is the root question. LHS is least common multiple. The LHS root property is A union B union A equals A union A union A. So this will basically that is the result first we can compute ahead of time, but that's the space we can compute. So it solves computation problems on the lattice. So it's not stored on the lattice because it's gonna be a verified problem in space. So you're gonna have two, you're gonna have the lattice space, you're gonna have the computation space. So theoretically, you're gonna have the full lattice. So have two lattice space you can build into. So in R2, so basically it's not done yet, but because I have a lattice, so let me try and look at the problem now. So I'm trying to find a problem. So the problem will be identify So that is basically there. So the problem space will be here. So computing the lattice points, circles and lattice, closing on the lattice. Because using the lattice, we're going to have two lattice points on one point. But the on a circle. So below that is put on a circle. So you have to line the plane because it's because if you have a paintbrush head, with more pressure you're gonna have the pen pressures grow with lattice, but the pressure can be mapped to a space in more time as you draw the system. So that's what I'm going to do. It's gonna have s squared plus y squared equals r squared. You're gonna map to a point as the more pressure you put. So if you have a pen tip of 10 pixels, let's say we have x squared plus y squared equals to r squared. R squared, where r is 10 pixels, x is the point A is uh, 10, 13, 13 on 10, 10, 13. So the point is 10, 13. So you're gonna have a a prime a a a a a equals minus 10, 13. A equals let me see. For all A, it's gonna have S squared. It's gonna have R squared. It's gonna have S squared. It's gonna have R squared. It's gonna do R squared. It's gonna do R squared. R squared. So you're gonna you're gonna find S squared. Square root of S squared. What's the calculator? It's in my bag here. It's in my bag. Don't in my bag. Please, in my bag is something. But I don't want to be using something to do it. No, it's too late for that. Let me just get it. Okay. So let me calculate it here. So you're gonna have r squared equals to s squared plus y squared. And you're gonna divide by x squared. So you're gonna do square root of x. So square root of r squared equals r, and that will be r equals the square root of x squared plus y squared. Then give you r. So r is square root of 10. So you're gonna have the square root of 10. So, roots. Square root of 10. 10 square roots is 100. What? 10 square root is 100. 10 divided by 1 square root 115. So basically, x is what? X is 10. X is 10. Y is 13. So square root of 10 is this my calculator is saying to me square root of 10. Square root of 10. So for this 10, square root of 10 is 100. 100. So 10 is 100. The square root of 13 is 169. It's 169. So the square root is a plus b. Because 10 times 10. Oh, that's not right. That'll be x squared 10 times 10 is 100. So 100 the square root of 100 plus 169. 100 plus 100 plus 169 is 269. 69. Now the square root of 69 will be 269. So basically, 269 square root. So 269 will be square root of 269. Square root 269. That will be 16. 16.401. 401 to 3 decimal places. Which is R. So R question for 41. So the goal is to have this work now. So it's gonna work now. So the lattice is defined as a space of so you're gonna try to work out. So you're gonna have the space preserved in memory. So you're gonna have the unit 10 10 10 as x. But 10 10 you have 10 10 you have 4 points, you have point 1 10 10 you have anything give you 100, so 10 10 give you 100. 10 minus 10, you're gonna have minus 10 10, you're gonna have 10 minus 10 minus 10, and they'll resolve to the circle radius because the shear lattice of space. You're gonna have the x sub a, x sub y, x sub b, which equals to so you're gonna have y. So now y will be 12. So this is y sub a and y sub b will be two systems of 12. 12 times 12 would be 69. No, I put 12, not 13. It will be 13 times 13. So it will be minus 13, 13. For all the conjugate orders too. So you have 4 sets of this. You have 2 sets. So you have the thing are 10 minus 10 minus 10, 10 minus 10, 10, 10, 10 minus 10 minus 10. And you have minus 10 on 2 sets. So these are 2 different sets that the system. So now the last step is to put them on the lattice. So that would be computing over the lattice. So you have 4 points that map onto the circle radius R that compute the lattice. So the lattice is basically a radius R. So I'm trying to map it to the lattice because if you're moving the pen, you're moving the pen in 2 systems, and you go to draw a smooth curve, a continuous graph with no jagged edges, given that area of R. So the area of R is the radius. You presume radius of the system. So that's what I'm saying. So should consider. So the preserve radius, you're gonna have the radius preserved by tracing out the path in Cartesian system, which is basically Hamiltonian path. Hamiltonian path. Hamiltonian path. You're gonna choose an Eulerian path. You're gonna take Hamiltonian path. So you're gonna have a Hamiltonian path. So between the system that joins Hamiltonian path. Hamiltonian path in graph is a traceable path defined by the path visiting each element in the graph exactly once. So so you're gonna have a traceable of a Hamiltonian path, which is a Hamiltonian circle. So it's a traceable path you can trace. So you can trace some Hamiltonian. So you're gonna have a tracing of the function. So if I have f sub x given x given x of x, x is a function. F of given equals f of s equal to so if you can make x a subject, that would be so if you can make x a subject, you can have x squared x squared. So you're gonna have x squared, f of x and f of y, and these are traceable functions in no time they trace over the point basically. So there's no control. So you're gonna have x of s of so you're gonna have 2 points to trace. So f of x will be f of x equals f of x equals to the square root of y squared minus r squared. In y we're gonna have s squared minus r squared. So you're gonna have the square root to give you some function of x equals to s. So you're gonna have the point traced over the third y squared minus s r squared. But because you have to manage it from each side, so you're gonna have it's gonna make x a subject and y should be function of t in time. So x of so this will be basically how it works basically. So this is a lot of analysis. So you're gonna have a system of administrative properties there. So uh, uh, so this one works so far, guys. F of x equals f of y. S squared plus minus squared. So ask for this radius. So this is 16.401, and 16.401, and y squared is y squared is y squared is basically I'm just going to harmonic system. The part of the harmonic system is in the square, but it can't be a third. It has to be a function of growth. So it's going to have the set denotation. So you're going to have a system of non-relative because give me continuity. You're going to have a continuous curve. So actually the formula is going to have r equals f squared equals y squared minus r squared. So you're going to have a square root of r squared. It's going to have a minus r squared. So the square root of x and f of x give us f of x sub a. Okay, f of x sub sub a given a sub a will give us a f of a. So this will fit into a, where a is between between the range of 10 less than or equal to 10. So this is f of f x of a, f of a, f x of a, f x of a, is mapped to 10 minus 10 less than or equal to a, less than or equal to 10. At all time is equal to plus 10. So if you go from 10 to minus 10, basically, I'm gonna get f x of b. I'm gonna go from because it's b, it's going to be, it's gonna go from minus 13 less than or equal to b less than or equal to plus 13. And this is the mapping space. So the map between the space. So it can trace anyone based on the channel. This is as increases, your goal management will just increase based on the errors of the way to come. So the parent pressure basically is a parent pressure model. I think that's what you do. So let's go here. So that's I'm doing distance there. That's the range distance there.